Hi, welcome to the BVCN Python Lesson 5, part of our live coding elements that we've been doing now with our Python channel. And so what I like to present here is a bit of code that answers this particular setup and problem that can be a pretty common one amongst people working in bioinformatics trying to download genomes from NCBI. So one of the elements that is updated pretty regularly at NCBI is in GenBank a file called assembly_summary_genbank.txt, which has a large number of identifiers that are in some cases unique and in some cases not, for all of the genomes in GenBank, which you can access through the GenBank FTP address. And currently, the full version of this file is 212 megabytes and contains 722,000 genome entries. And so what I commonly find myself looking to do is taking some set of identifiers, parsing through the assembly summary genbank.txt file, and then outputting those elements in a way that would allow me to download the files directly from the FTP site using the wget command from Unix. And so in this particular example, I've designed a script and some workflow that will allow us to do this in a subset of GenBank, of the GenBank file, which contains 15 entries with two different sets of identifiers that target different elements of this file to begin with. And so if we were to launch the binder or to follow along in the repository, the final script that was coded would look something like this, where I'm using the sys library as our way of importing the file that we want to look at in terms of unique identifiers. I'm setting an initial list that is blank, that will contain the unique identifiers for our genomes that we're interested in. And then what I'm going to do is I'm going to parse through the file, which is the second entry in our sys.argv list that gets generated with our import list library. And so what I'm going to do is I'm just going to parse through each line of the file that comes up. And so our file just consists of a single column with one return at the end of the line that has an identifier that we're interested in. And so I'm going to loop over this using a for loop. I'm going to say for line. So each individual line is being read off and stored in a variable called line from a file, which we can assign with our Python script called sysargv, which will be sysargv1, which we're reading into our reading in only. At this point, I would need to append and store the identifiers in my genome list. And so I can do this. I'm doing two steps at once here. So the first step I'm doing is I'm removing the white space that's at the tail end of each of the identifiers because there's a new line there. And then once that's cleaned up, I'm going to append this into our genomes list. And so right now I'm going to take I'm taking our single copy, single column unique identifiers and adding them into a list format. Then what I want to do, and so this is partially a reason to do this would be, or the reason to do it this way is because both sometimes when you're downloading genomes, you're looking for a lot of genomes, and the assembly summary GenBank file, when you're using the full version of it, is very large. And so if we read that file into a dictionary, we can access that information more quickly than if we read it into a list or compared each entry of the assembly GenBank file to a list as we went along. So by doing this in two steps, we actually are faster than if we did it in one step where we have a list and we read through the whole file line by line, looking for the individual match. Especially as this list gets longer, the time it would take to compute that actually can take minutes at that point in time as opposed to seconds when we put it into this dictionary format. So again, I'm reading in a line, opening this particular file as opposed to the file that we gave the script in the first place. It's a read only, so we're going to read in using this R. So the formatting of the assembly summary GenBank file is that the first two lines actually have a pound symbol representing that they're the header lines. And so what we can do is we can check to see if the line that we're looking at is a header line or not a header line. And the way we do that is we use an if statement. We use this if line. If the first position in your line is a pound statement, we don't want to deal with it. So here we're saying if line, first element, is not pound, so all other lines, not the header lines, then we're going to do some element to it. So here we're gonna remove the trailing new line character from the line. So we can do that by taking line, running strip on it, and then reassigning it to the original variable. So this just keeps the line in place and resets it. Then we can create a list that has all the elements in the line populated into it, and we can do that using split. So split by nature, if this wasn't here, this open quotes tab element, close quotes, split would automatically split on white space. And that would be good for us because organism names have white space in them. Organizational names have white space in them. So each line potentially could have a different number of columns if we just used white space. So we explicitly say split on the tab, and then each element of our data list is then tab separated, and we end up with each column getting its own element in our list. And then here is where we actually have to do some analysis of our data before we can actually move forward here. And so we have to select which column matches up with the type of file that we're reading in. And so in the type of file that we have two examples. One, we use a taxon ID. One, we use a unique identifier that was related to a single amplified genome. In this particular instance, if we read in our taxon ID file, what we can do is we want to use that as the key in our dictionary, and that happens to be the sixth element in our list, and so index number 5. And so what we're setting here is we're setting a key value equal to the taxon ID that's being observed, and then we're setting it to our 19th column, which happens to be the FTP address for this particular genome that we're dealing with. So we populate a dictionary that has a key value pair of that, where we have a taxon ID as our first element, and then FTP as our value that it's linked to. And then I'm going to write two files as our output files. The first output file, which we'll open and store in a variable called outfile1, will be all of the elements that match correctly. So this will be anything that is in our identifier list that we can find in the assembly list that then has an FTP address. And then we're explicitly writing out to that file here. Out file number 2 will be all elements in this index list or identifier list that is not matched in our dictionary here from the assembly GenBank file. Right? Again, writing that out, two separate files. So we have the ones that match and the ones that don't match. So now we need to iterate through our list of identifiers. And again, this is in this particular format, we're doing this because this runs very quickly and allows us to get the information back relatively fast. It allows us not to have to read through each of these very long lists multiple times. And so the way we do that is we iterate through our identifier list for I in genome. So we're creating this for loop, iterating through the list. So each index in our list has a element, and that's now being stored in I as we go through it. And then we're going to use a formatting called a try except formatting. And so this is common throughout Python, but we're using it specifically to exploit some of the elements of dictionaries. So dictionaries, when they're read in, are read into active memory. So even if they're fairly large, they can be read into memory. And then when you query a key in a dictionary, that happens very quickly. It doesn't require reading through all of the dictionary. It doesn't require reading all of the keys. It can find the key very quickly based off of the way it's stored in the memory and indexed. So what we can say is try. So what we're asking to do is attempt this thing, and we're outputting to our file 1, our target file, our correct file, anything that has a match. We're using it and we're setting it up, and we're going to set it up formally so that it looks exactly like what we want to do as our next step to download the file. So in that case, we're going to be using wget. There's a space here because we want to format this the way we would a Unix command line. And then here I'm using our unique identifier to search our big dictionary with the key I, right? So the first identifier is some unique element. We ask, is it in the dictionary? The dictionary says yes. The dictionary then returns back the FTP that we're looking for because that's the formatting here. So we get some string that represents a FTP address, web address. And then we want to get a specific file out of the FTP site. And so to do that, we say, okay, treat this as a directory, and then look for specifically a file with this wildcard that ends in genomic.fna.gz. And so this would go in, create a set of matches that have wget as the command that we're going to use from Unix, an FTP address, along with the file that we're going to pull down from the FTP address. And then we're going to explicitly say create a new line here so that each one is on its own line. So it's possible that we provide an identifier in our list that's not in the assembly GenBank file. And so that if we did that and we submitted this to the dictionary and said, hey, get this key, we'd get returned an error that said that we were missing a key, and it's called a key error. And we know that that might happen. So what we can do is we can create an exception for that. So we can say, except in the case of a key error. So in this particular instance, we're reading in and saying, if this matches, print this out. If it doesn't match, instead of failing, and if it's particularly a key error, just let us know which one didn't work here. So in this particular instance, we're just taking the index that didn't work, outputting it to our second file with a new line, and then giving us a list of identifiers that didn't work in this particular instance. And so that way we can then parse through this file. And so if we ran this here, so we can do Python parse. We want to give it a file that we're working with, which is our taxon IDs situation for this. And then we hit enter. Now when I look at our matches, we get this set up here where it says wget, there's a space. This is the FTP address that contains the genome for this one particular organism. If we want, we can make this an executable like this, where we then are now able to run that on our command line and pull down files using that wget command. And then if we look at our unmatched elements, there were some elements in our index list or our identifiers of interest that weren't present in our particular GenBank assembly file. And so they get stored here, and we can access them and go back in and see if our error was because they're not actually in the assembly file, which is the case in this instance, or if they might potentially be in a different column than we expected them to be in. And so with that, I'm going to conclude. Thank you for joining, and we'll see you next time.